Hi, I'm Ed Sperling. I'm the Editor-in-Chief of System Level Design. I'm here with John Lenyo of Mentor Graphics. John, chips are becoming incredibly complex, and while that has lots of ramifications in a number of areas, it certainly has a big ramification on what's going on in verification.
Absolutely.
We have to deal with not only the divide and conquer, we have to deal with the system level verification. How do we marry those two?
Yeah, what you're seeing, Ed, now, I think people understand how to do block-based verification. They seem to have that under control. I'm okay. And the issue is right what you're talking about, the SOC Merge. So you've got both the, how do we stitch together processors, buses, all the peripherals by a person who really doesn't know how the individual blocks work. And then the second thing is how do you bring the software people into the verification process early. So what we're seeing our customers starting to really get interested in is certainly the standard simulation techniques that they've used for years, formal and static analysis to try to harden the IP so they don't have to re-verify it over and over again. And then for the really long tests, we're seeing an explosion in emulation. So people that want to run video, networking, make a cell phone call, do all that stuff on the SOC and get their software people involved are starting to really amp up the amount of vectors they can get through their design in any given second by using some hardware acceleration. So that's a big trend that we're seeing in this space.
You know, one of the interesting things about what you're addressing here is that we're starting to deal with more IP blocks that are not necessarily developed by the people that are putting the chips together. Some of these are basically black boxes.
Yep.
And so you're trying to verify things that you know nothing about, right?
Absolutely.
How do you do with that?
So the interesting thing is the stimulus, for these SOCs, it tends to be more and more now, the one thing they do tend to have in abundance is software. So and to run software, to boot the processor, to get the thing into a state that's interesting, we are starting to see this, a lot of these kind of emulation techniques. The other thing we're seeing with the black boxes is people trying to avoid verifying them at all. So if they've been to silicon, they're golden, they can harden them with assertions, other things they put around so that you can actually check the interface to make sure that, okay, I didn't break anything when I connected this HDMI macro to the AMBA bus, it just works.
Assertions are not easy for a lot of engineers to get. We're talking about a formal way of looking at things, and it requires a lot of positioning up front of what am I trying to figure out, what am I trying to do here.
Yep.
How do we change that?
This is a sweet spot of Harry Foster, who works for us at Mentor Graphics. He's trying to educate people on the effective use of assertions in design. Right? He actually has an example where he wrote 2 lines of system Verilog. It looked like some combination of Latin and Greek, and what they're trying to really check is that 2 clock cycles, 2 pulses don't happen at the same time or happen in a row, right? So there is it's just a thing that people are going to have to go through in terms of education. We are trying to do more automation, and so use our formal engines to find some of these structural problems without having to write the assertions. So there's a much more powerful suite of tools out there now that are doing some of this automatic static checking so that you don't have to write them all. But in terms of writing them, we're seeing more and more adoption. I mean, the latest survey we did showed 2/3 of the people claim they're using them, whether they're writing 10,000 or 4. I can't tell you, but it seems like it's necessary going forward. But you're right, it's like UVM, it's like any language. It's something people are just going to have to get trained on and be willing to put in the time to learn it.
The numbers that I've heard tend to vary, but as we start adding more software in, the NRE piece of the verification cycle seems to be running as high as almost 85% in total when you start considering the hardware as well as the software. Is that ever going to go down, or are we just seeing this trending up forever as more pieces are added in?
I missed the first part of that. Can you run that?
In terms of the total NRE on an SOC?
Oh, okay. There's been a number of studies. Some are showing software exploding versus hardware. I've heard people kind of refute that or say it's not as bad as you think. I think Gary Smith said a SOC now is $50 million, something like that, to get one start to end. But I can tell you that most of the people I talk to, their software teams are a lot bigger than their hardware teams. So I don't see that changing a lot going forward.
The other thing that seems to be happening, though, is as we start getting all this incredible complexity, we don't necessarily know when something is done or done with a comfort level.
Right.
So we're always going back on, can we fix this in software? Have we really engineered this correctly so that this is all solvable with the verification process and we're going to catch all the bugs, or are we going to be just living with these things going out forever?
Right, and you've hit on, we go out to customers and we do these verification assessments where we literally start with, what are you trying to do? We don't, it's just walk them through what they're trying to do, and we're finding that one of the biggest areas that people need to work on is exactly what you're getting at, which is planning up front. So, what does verification mean? When do I know that I've actually done enough? What functions do I have to check? Can I instrument my tools that I keep track of that as I'm going along, so I have some idea metric-wise where I am? Especially now with all the, like you said earlier, with the people that are putting these chips together but don't really know how all the black boxes work. They need some sort of indication of, think I'm done. So between the verification planning up front and driving metrics and functional coverage, some of the other techniques we're seeing being used now, people are trying to go at it a much more sophisticated way than, hey, the bug charts come down. We haven't found a bug in 2 weeks, maybe it's time to tape out, which is historically what's been done.
How far is up front? I mean, what are we talking about? Are we talking the architectural stage where they're actually thinking verification, or are we thinking...
Oh, absolutely. I mean, they're thinking verification from, once they figure out what's in hardware and what's in software, you have a plan. Now, you hear a lot about verification methodologies, and people throw around OVM and UVM. Those are just test bench architecture methodologies. Verification methodology is a much bigger and broader space that involves, what's my coverage model look like? What do I have a high-level model and an RTL level model? Am I going to compare them? Where's my reference model? How am I actually figuring out that what I'm doing is correct? And so it's one of the most interesting areas of EDA. It's certainly quite challenging for people, and we think verification is. I guess, what's the right way to put this? An infinite sort of area of challenges and new solutions you're going to see. And the rate of stuff that's come out the last 4 or 5 years has probably been 10x what you would have seen in the previous 4 or 5 years, just in terms of the industry horsepower, the engineering time in EDA companies being thrown at trying to figure this problem out.
Has anybody ever put together something that says, okay, we're about to institute an engineering change order right at the last minute? What do we have to do for verification? How much is this piece going to cost us?
That's an interesting question, and that's done pretty much differently everywhere you go. Nobody really has the same way of doing it. Kind of depends where you are, right? If you're post-synthesis, post-place and route, and somebody changes a function, you got a whole bunch of other problems than, did my function change correctly, right? The upfront side, it's the nice thing is now with all these metrics and things, you can actually pretty quickly find out, okay, I changed this block of code. What tests actually hit that block of code? I'm just going to go back and rerun that set of tests. It just depends on where you are. I mean, later it gets much more expensive.
John Lenyo, thank you very much for your time.
Thanks, Ed. Good talking to you again.